Welcome back to the Tech Think Tank. In our previous video, we explored the basics of building web applications with Java Spring Boot. Today, we're excited to bring you the part 2 of our step-by-step guide. In this video, we'll dive deeper into the world of Spring Boot and cover advanced topics such as building the web application, adding functionality with Spring Boot libraries, testing and debugging the web application, and deploying the web application. Whether you're a beginner looking to take your first steps in web development or an experienced developer looking to enhance your skills, this video is for you. So grab your coffee and let's get started. If you haven't seen part 1 of this video, then click the pop-up banner now or the link in the description below to watch it first. I recommend you to watch part 1 first and then watch this video. In part 1 of this video, we have covered so far how to set up the development environment, create a new Spring Boot project on different IDEs, and how should we set up the database. Let's continue with the remaining topics now. We will cover these topics in our video as we go along. Building the web application. Adding functionality with Spring Boot libraries. Testing and debugging the web application. Deploying the web application. To learn more about these topics, stay tuned to the end of the video. Let's continue our journey by building the web application first. To learn more about it, we need to divide building the web application into 4 subtasks. 1. Creating a new controller class. 2. Writing methods for handling requests and responses. 3. Adding views and templates for displaying data. 4. Configuring security settings for the application. Let's learn about these subtasks in detail. To create a new controller class for a Java Spring Boot application, we need to follow a few steps. Once you follow these steps, you will be able to create a new controller class. 1. Identify the business logic, determine the functionality that the new controller will provide. For example, it could handle user authentication, retrieve data from the database, or perform calculations. 2. Create a new Java class. In your IDE, create a new Java class and give it a meaningful name, such as user controller. 3. Add the @REST-controller annotation. Add the @REST-controller annotation to the class definition. This tells Spring that the class will handle HTTP requests and return JSON responses. 4. Add request mapping annotations. Add @request mapping annotations to each method in the class that will handle HTTP requests. The annotation should specify the HTTP method, GET, POST, etc., and the URL path that the method will handle. 5. Implement the business logic. Write the code that implements the functionality for each request mapping method. This could involve calling services, accessing the database, or performing calculations. 6. Test the controller. Run the application and test the controller by sending HTTP requests to the URL specified by the request mapping annotations. Verify that the controller returns the expected JSON responses. By following these steps, you can create a new controller class for your Java Spring Boot application. This will enable you to handle HTTP requests and implement the business logic of your application in a structured and organized way. Once the controller class has been created, it's time to write methods for handling requests and responses. Here are the steps to write methods for handling requests and responses in a Java Spring Boot application. 1. Identify the request and response data. Determine the data that will be sent in the HTTP request and the data that will be returned in the HTTP response. For example, a GET request might return a list of user data in JSON format. Define the method signature. In your controller class, define a method with a signature that matches the request and response data. For example, if the GET request returns a list of user data, the method signature might look like this. 3. Implement the business logic. Write the code that implements the business logic for the method. This could involve calling services, accessing the database, or performing calculations. 4. Return the response data. Use the appropriate return type to send the response data back to the client. For example, if the response is JSON data, you can return a list user object and Spring will automatically convert it to JSON. 5. Test the method. Run the application and test the method by sending HTTP requests to the specified URL. Verify that the method returns the expected data in the expected format. By following these steps, you can write methods for handling requests and responses in your Java Spring Boot application. This will enable you to implement the functionality of your application in a structured and organized way, and provide data to clients in the format that they expect. Our next topic discusses how to add views and templates for displaying data. To add views and templates for displaying data in a Java Spring Boot application, there are 6 procedures that you need to follow. 1. Determine the data to be displayed. Decide on the data that you want to display in the views. For example, you may want to display a list of users or a single user's profile. 2. Choose a template engine. Select a template engine that is compatible with Spring, such as Timeleaf or FreeMarker. 3. Create a template file. In your project's resources directory, create a new template file with a file extension that corresponds to your chosen template engine. For example, if you're using Timeleaf, create a new file called users.html. 4. Add the necessary HTML and template code. Write the necessary HTML and template code to display the data that you want to show. This will typically involve iterating over a collection of data and displaying it using HTML tags and template variables. Here's an example of Timeleaf code to display a list of users. 5. Create a controller method to return the view. Write a controller method that returns the view containing the template. This will typically involve retrieving the necessary data from a service or repository and passing it to the view as a model attribute. Here's an example of a controller method that returns the user's template. 6. Test the view. Run the application and test the view by navigating to the appropriate URL in your web browser. Verify that the data is displayed in the format that you expect. By following these steps, you can add views and templates for displaying data in your Java Spring Boot application. This will enable you to create dynamic web pages that can show data to your users in an organized and visually appealing way. Configuring security settings for the application is one of the most important processes in Spring Boot. There are exactly 6 steps to configure security settings for a Java Spring Boot application. 1. Add Spring Security Dependency. Add the Spring Security Dependency to your project's pom.xml or build.gradle file. For example, to use Spring Security 5, you can add the following dependency. 2. Configure Spring Security. Create a new class that extends Web Security Configure Adapter and annotate it with @enable web security. Override the configure HTTP security HTTP method to specify the security configuration for your application. For example, you can require authentication for all requests, allow access to certain URLs without authentication, and specify which authentication mechanism to use. An example code snippet is flashing on the screen now. In this example, requests to /login and /signup are allowed without authentication, while all other requests require authentication. A custom login page is specified, and after successful authentication, the user is redirected to the home page. 3. Add User Details Service. Create a new class that implements User Details Service to provide user details for authentication. This can be done by implementing the load user by username, string username, method to retrieve user details from a database or other storage mechanism. An example code snippet is flashing on the screen now. 4. Configure Authentication Manager. Override the configure Authentication Manager builder auth method to configure the Authentication Manager to use the user details service created in the previous step. An example code snippet is flashing on the screen now. 5. Test security settings. Run the application and test the security settings by accessing URLs that require authentication. Verify that unauthorized access is redirected to the login page, and that authentication is required to access protected URLs. That's it. By following these steps, you can configure security settings for your Java Spring Boot application. This will enable you to protect your application from unauthorized access and ensure that user authentication is handled securely. Our next stop is functionality. Let's see how we can add functionality with Spring Boot libraries. To do this, we need to follow 3 subcategories. They are: 1. Overview of Spring Boot libraries. 2. Adding libraries to the project. 3. Using libraries to simplify web development tasks. Let's explore them in details. Now let me give you an overview of some of the important Spring Boot libraries. 1. Spring Framework. Spring Boot is built on top of the Spring Framework, which provides the foundational features for building Java applications. Spring Framework includes modules for dependency injection, data access, web applications, and more. 2. Spring Data. Spring Data provides a consistent way to access data from different data stores, such as databases, NoSQL data stores, and search engines. Spring Data includes modules for MongoDB, Redis, Cassandra, and more. 3. Spring Security. Spring Security provides a powerful and flexible way to secure web applications. Spring Security includes modules for authentication, authorization, and web security. 4. Spring MVC. Spring MVC provides a model view controller, MVC, architecture for building web applications. Spring MVC includes features such as request mapping, view resolution, form handling, and more. 5. Spring Boot Actuator. Spring Boot Actuator provides production-ready features for monitoring and managing your application. Actuator includes features such as health checks, metrics, and management endpoints. 6. Spring Boot Dev Tools. Spring Boot Dev Tools provides a set of tools to enhance developer productivity. Dev Tools includes features such as automatic restarts, live reloading, and remote debugging. 7. Spring Cloud. Spring Cloud provides a set of tools for building cloud-native applications. Spring Cloud includes modules for service discovery, configuration management, circuit breakers, and more. If you want to know more about cloud computing, click the pop-up banner now or the link in the description below. I can wait while you watch the cloud video. These libraries are just a few of the many that Spring Boot provides. By leveraging these libraries, developers can rapidly build and deploy high-quality Java applications with minimal setup and configuration. Next up are libraries. Let's learn how to add libraries to the project. By following a few simple steps, we can easily add libraries to a Spring Boot project. 1. Determine which libraries you need. Before adding a library to your project, you need to determine which libraries are necessary for your application. This can depend on the requirements of your application, such as the need for a specific database driver or security library. 2. Add the library to your project dependencies. Once you have identified the necessary libraries, you need to add them to your project dependencies. In Spring Boot, you can do this by adding the library to the pom.xml file if you are using Maven, or the build.gradle file if you are using Gradle. For example, if you need to add the Spring Data JPA library, you could add the flashing dependency to your pom.xml file from the screen. 3. Refresh the project dependencies. After adding the library to your project dependencies, you need to refresh the dependencies to ensure that the library is downloaded and available in your project. In most IDEs, you can do this by right-clicking on your project and selecting Maven or Gradle-refresh. 4. Use the library in your code. Once the library is added to your project dependencies and refreshed, you can use it in your code. For example, if you added the Spring Data JPA library, you can use it in your code by importing the necessary classes and annotations, such as at entity and at repository. It's that simple. You can easily add libraries to your Spring Boot project using these steps. As we have now added libraries to the project, let's now learn how libraries can simplify web development tasks in Spring Boot. Here are some most used libraries examples. 1. Timeleaf. Timeleaf is a template engine that allows you to easily create dynamic HTML pages. With Timeleaf, you can use template expressions to render dynamic data and create reusable components. Timeleaf also integrates well with Spring Boot, making it easy to use in your web applications. 2. Spring Data JPA. Spring Data JPA provides a high-level abstraction over data access, making it easy to work with databases in your Spring Boot applications. With Spring Data JPA, you can easily perform CRUD operations and execute complex queries without having to write boilerplate code. 3. Spring Security. Spring Security provides a powerful and flexible way to secure your web applications. With Spring Security, you can easily add authentication and authorization to your application, as well as protect against common security threats such as cross-site scripting, XSS, and cross-site request forgery, CSRF. 4. Spring Boot Actuator. Spring Boot Actuator provides a set of production-ready features for monitoring and managing your application. With Actuator, you can easily monitor your application's health, performance, and other metrics, as well as manage your application using endpoints such as shutdown and restart. 5. Spring Boot Dev Tools. Spring Boot Dev Tools provides a set of tools to enhance developer productivity. With Dev Tools, you can automatically reload your application when changes are made, debug your application remotely, and more. By leveraging these and other libraries in Spring Boot, you can simplify many web development tasks and focus on building your application's unique features and functionality. Now we have built our web application successfully, it is time to test and debug them. And it consists of only 2 subtasks. They are: 1. Writing unit tests for the application. 2. Debugging the application using the IDE. Let's explore these 2 subtasks in detail. Spring Boot application unit tests can be written in the following ways. 1. Choose a testing framework. There are several testing frameworks that you can use for testing Spring Boot applications, such as JUnit and Mockito. Choose a framework that best fits your needs. 2. Create a test class. In your IDE, create a new test class for the component that you want to test. For example, if you want to test a controller class, create a test class for that controller. 3. Annotate the test class. Annotate the test class with the appropriate testing annotations for your chosen testing framework. For example, if you are using JUnit, annotate the test class with @runWith, springrunner.class, and @webmvctest, mycontroller.class, to indicate that you are testing a Spring MVC controller. 4. Write test methods. Write test methods for each component that you want to test. For example, if you are testing a controller, write test methods that send mock requests to the controller and verify that the expected response is returned. 5. Run the tests. Run the tests in your IDE or using a build tool such as Maven or Gradle. You should see the results of the tests in the test runner output. 6. Refine and iterate. Refine your tests as needed, adding more test cases or adjusting existing tests to improve test coverage and ensure that your application behaves as expected. By writing unit tests for your Spring Boot application, you can ensure that your application behaves correctly and meets its requirements. Unit tests can also help you catch bugs early in the development process, before they become more difficult and costly to fix. The following steps will guide you through debugging a Spring Boot application in an IDE. 1. Set breakpoints. In your IDE, set breakpoints in the code where you want the debugger to stop and allow you to examine the current state of the application. 2. Start the application in debug mode. Start your Spring Boot application in debug mode by adding the appropriate flag to the command used to start the application. For example, if you are using Maven, you can start the application in debug mode by running the command mvn springboot, run springboot.run.jvm arguments equals debug, zrunjup, transport equals dt_socket, server equals y, suspend equals y, address equals 5005. 3. Connect the debugger. In your IDE, connect the debugger to the running Spring Boot application by configuring a remote debugging session. The specific steps for doing this will depend on your IDE. 4. Examine the application state. Once the debugger has stopped at a breakpoint, you can use your IDE's debugging tools to examine the current state of the application. For example, you can inspect variables, step through code, and view the call stack. 5. Continue execution. Once you have examined the application state, you can continue execution of the application by resuming the debugger. 6. Repeat as needed. Repeat the process of setting breakpoints, starting the application in debug mode, and examining the application state as needed to identify and fix issues in your Spring Boot application. By debugging your Spring Boot application using an IDE, you can quickly and easily identify and fix issues in your code, helping you to create a more stable and reliable application. Wow, I can't believe that our application is almost ready for a consumer to consume. The last bit is deploying the web application. There are just 2 more subtasks to follow so that we can deploy the web application. They are: 1. Packaging the application into a JAR file. 2. Deploying the application to a web server. Let's learn about them to deploy our application successfully. Let's now explore the steps for packaging a Spring Boot application into a JAR. 1. Build the application. Before packaging the application, make sure that you have built it by running the mvn clean install command or the equivalent command for your build tool. This will compile the application code and create the necessary artifacts. 2. Configure the packaging options. In your pom.xml file, add the necessary configuration options for packaging the application into a JAR file. This typically involves setting the packaging element to jar and configuring the Maven jar plugin to include the necessary files and resources. 3. Package the application. Run the mvn package command or the equivalent command for your build tool. This will create a JAR file in the target directory of your project. 4. Verify the package. Verify that the JAR file was created successfully by checking the target directory of your project. You should see a JAR file with a name that corresponds to your application name and version. 5. Run the application. To run the packaged application, use the jar command followed by the name of the JAR file. For example, if your JAR file is named my app 1.0.0.jar, run the command jar my app 1.0.0.jar to start the application. By packaging your Spring Boot application into a JAR file, you can easily distribute and deploy your application to different environments without having to worry about dependencies or configuration issues. Let's now deploy the Spring Boot application to a web server. To do that, we need to explore 6 easy steps. 1. Choose a web server. Before you can deploy your Spring Boot application, you need to choose a web server to host the application. Common options include Apache Tomcat, Jetty, and Undertow. 2. Package the application. Package the application into a JAR file using the steps outlined in the previous response. 3. Configure the web server. Configure the web server to run your Spring Boot application by creating a deployment descriptor file, e.g. myapp.xml, that specifies the context path and location of the JAR file. 4. Deploy the application. Deploy the application by copying the JAR file to the appropriate location on the web server and starting the server. 5. Verify the deployment. Verify that the application was deployed successfully by accessing the application URL in a web browser. If the application is working correctly, you should see the application homepage or landing page. 6. Monitor and manage the application. Monitor and manage the deployed application using the web server's management console or other monitoring tools. By deploying your Spring Boot application to a web server, you can make your application accessible to users over the internet and take advantage of the scalability and reliability features provided by the web server. There you have it. We have finally built a web application using Java Spring Boot. I would like to recap what we learned in these videos. 1. Setting up the development environment. 2. Creating a new Spring Boot project. 3. Setting up the database. 4. Building the web application. 5. Adding functionality with Spring Boot libraries. 6. Testing and debugging the web application. 7. Deploying the web application. If you want to learn more about Java Spring Boot, I can suggest some learning materials for further learning on Java Spring Boot. 1. Official Spring Boot documentation. The official Spring Boot documentation is a great place to start learning more about the framework. The documentation covers everything from getting started with Spring Boot to advanced topics like security, testing, and deployment. 2. Spring Boot tutorials. There are many online tutorials available for learning Spring Boot, including video tutorials on YouTube and written tutorials on various blogs and websites. Find a tutorial that suits your learning style and work through the examples provided. 3. Online courses. There are many online courses available on platforms like Udemy, Coursera, and Pluralsight that cover Spring Boot in depth. These courses provide a structured learning path with hands-on exercises and assignments to reinforce your learning. 4. Books. There are many books available on Spring Boot, including Spring Boot in Action by Craig Walls and Learning Spring Boot 2.0 by Greg L. Turnquist. Books provide a comprehensive and in-depth understanding of the framework and are a great resource for reference. 5. Community resources. The Spring Boot community is very active and supportive, with many forums, blogs, and discussion boards dedicated to the framework. Participating in these communities can help you learn from others and stay up to date on the latest developments in the Spring Boot ecosystem. By exploring these resources, you can gain a deeper understanding of Spring Boot and become proficient in developing high-quality web applications with the framework. Oh, one more thing, this video has not been sponsored by any of these resources, nor am I endorsing them. It is just my recommendation.
Congratulations! You have successfully completed our step-by-step guide on building web applications with Java Spring Boot. We hope this video has helped you gain a solid understanding of Spring Boot and how it can be used to build robust and scalable web applications. If you enjoyed this video, don't forget to give it a thumbs up and share it with your friends and colleagues who are interested in web development with Java. And if you're looking for more tech-related content, be sure to subscribe to our channel, the Tech Think Tank, for regular updates on the latest trends and technologies. Thank you for watching, and we'll see you in the next video. Until then, stay curious and keep exploring the world of technology.